Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 5 of the video on reciprocal trig functions. I'm going through another example of solving a reciprocal trig equation. So here we have solved the equation 3 sec squared theta equals 4 between 0 and 2 pi. So the first thing that I need to realise is that this one is in radians mode. So before I do anything else on my calculator, I'm going to change the angle unit to be radians so that I don't have to do that halfway through and end up forgetting to do it and making a mistake. Now, 3 sec squared theta equals 4. Now, just with the previous one, we're going to need to divide by the 3 first. To give you 4 over 3. Now we can take the reciprocal because we have sec, and the reciprocal of sec is cos, so I can now write that cos squared theta equals 3 over 4. Now, importantly, cos squared theta is the same as cos theta squared, so to get to just cos theta I need to square root, which means I square root the right hand side. I square root 3 over 4. But what people always forget is that when you square root you get plus or minus. It's plus or minus root 3 over 2. So I'm actually going to get 2 sets of solutions for this equation. One of them is going to come from cos theta equals root 3 over 2. And the other one is going to come from cos theta equals negative root 3 over 2. And I need to do each one separately, 2 separate cast diagrams to get a total of 4 solutions. So, cos inverse of root 3 over 2 in radians mode, you should all be telling me is pi over 6, but we better just check. So cos inverse root 3 over 2, yeah, there you go, it's pi over 6. So putting that onto a cast diagram. Now think about how you label this because we're now in radians. So it's 0, it's not 90, it's pi over 2. It's not 180, it's pi. 3 pi over 2 and back round to 2 pi. But it is still a S, T, C for the label of the quadrants. Now pi over 6 is less than pi over 2, so it's going into this quadrant on my cast diagram. That angle there represents pi over 6. And now here, the value of cos is positive, which means I want the A quadrant and the C quadrant, not the sine quadrant or the tan quadrant. Which means that my second solution is drawn in the cos quadrant, and the angle with the horizontal is pi over 6. When I come to get that as an angle though, I need to go anti-clockwise round from 0, which means that I'm going to be doing 2 pi, because remember the whole thing is 2 pi, not 360, minus pi over 6, which is 11 pi over 6. So that means my 2 solutions from this part are that theta equals pi over 6 and 11 pi over 6. So 2 answers from there. Now over here, cos inverse of negative root 3 over 2. Which is 5 pi over 6. And again, stick that onto a cast diagram just like this one. So again, 0, pi over 2, pi, 3 pi over 2, and 2 pi, A, S, T, C. Now 5 pi over 6, 5/6 is more than a half, so going around here it's going to go into this quadrant on my cast diagram, and that angle there is the angle 5 pi over 6. Now here, cos of theta is a negative number, so I want the 2 quadrants where cos is negative, which is sine and tan, not all, not cos. Now the fact that cos is negative, that's why our principal solution has ended up in the sine quadrant. It's a negative number. So the other place we need to draw it is in the tan quadrant here. This angle now with the horizontal is 5 pi over 6. But remembering we measure these angles anti-clockwise from O. So going round like so, we're going to be doing 2 pi minus 5 pi over 6. 2 pi, remember, would be the full circle. And that is going to give us 7 pi over 6. So our two solutions for cos theta equals negative root 3 over 2 are theta equals 5 pi over 6 and 7 pi over 6. So 4 solutions in total, 2 from the positive root, 2 from the negative root, and that is the biggest thing that people forget when they're doing these. They get to cos squared equals 3 over 4, they square root both sides but forget the plus or minus, and by doing that you lose half the solutions. So take that as your key learning point from this one.